Good morning. So this session is about serverless. My name is Shen, and I'm in the public sector specialist team. So my domain area is like DevOps, serverless, containers. So today I'm going to walk you through how to developing a serverless application on AWS. So for folks are not familiar with AWS serverless, I'm going to do a brief overview, but just want to mention that serverless get a lot of traction and momentum in the past few years. So StackOverflow.com, they run a yearly survey for the developers all over the world. Serverless platform has been ranked #2 this year as the most loved platform right after Linux. So developers really love serverless. And we're super excited this year for the DC Summit because it's the first time we really have a serverless track for our summit. So we have sessions from getting started for serverless. We have sessions for architecture, serverless. We have this session for developing serverless applications. We also have sessions for serverless, do data analytics, and use case for security and cyber ops. So very exciting for this year. Just level setting. This session is not really 100 level, so I'm really expecting you guys know some basics about software applications, know a little bit about like AWS, at least all the service names. So I'm not going to really explain them too much. With that, let's get started. So, agenda. First overview, then walking you through a scenario, like how a developer really developing an application. Then I'm going to do a live demo. Overview. So what serverless mean? Is it another like managed service? Yes, it is a managed service, but when the developers doing serverless applications, they really don't need to think about servers, any infrastructures. They just need to focus on their code, do their business logics, upload the code, then we run them for you. You really don't need to pay for the infrastructure if you don't use them. Some benefits on the right side. So we will take care of the scaling for you. If you have a lot of traffic, a lot of workloads, we automatically scale for you. If you don't, we scale down, so you don't need to pay for anything. When we build a service, we always think about highly available. And again, there's no server for you to provision, which means you don't have the hassle to patch the server. And you greatly reduce your attack surface because nobody really can log into or SSH to your application because there's no server to log into, right? Some building blocks for serverless applications. So before we have Lambda, our serverless computing service, we already have a bunch of different services. They are like serverless. For example, simple storage service, S3. There's no server for you to manage. We have DynamoDB, which is a NoSQL server. So NoSQL database service, there's also no server. When you need another thing like a queue, we have a simple queue service. If you need email, we have email service. Those are our manager service. But when we have Lambda, it fills in the picture really nicely. Now you have the serverless computing service, which means all the developers can write their code and just run with Lambda. Then you can stitch all those things together. You can build reliable, secure applications on AWS. The latest service is AppSync, which I'm going to talk about. It's a GraphQL service we manage for you, provide you a lot of other benefits compared to like RESTful services. So I quickly mention about the community. So we have a huge community, third-party vendors, open source packages. A lot of people contribute to the serverless world. So if you want to look for example, if you want to build an application up top of something, you can do that too. Then we also have like partners doing like logging, monitoring, all those type of things for you. Because when you do service computing, a lot of times you adopt microservices architecture, manage all those services, how to do logging, how to do monitoring. A lot of time it's a challenge because all the services are like ephemeral, right? They come, we scale for you, and if we scale down, they're just gone. So they're really not persistent. So you really need some good solutions to manage the state, do the logging, and do the monitoring. So how we do the development? So a typical day for a developer is like your manager or your business side asking you, yeah, can we have this application because either somebody else have it or we really have this need for our customers. As a developer, of course, used to be like, yeah, I need a server provision, I need to do this, and I can write my code and build, compile, and upload and run them. But nowadays, you can see, I just make it serverless. So now what? Of course, before you do anything, you always follow the best practice. You start with like requirement analysis, understand the application. The worst thing would be you build an application which doesn't do the customer expects, right? You do high-level design, you do all those kind of typical things for developers. Comes to like design decisions, what to use, what kind of service, architecture you choose. For a serverless application, we need to answer like a bunch of questions. Do we need like APIs? Do we need to use a database? And how we are going to serve those static content, dynamic content, all your business logics. Let's answer the questions one by one. The first thing, like APIs. For APIs, we already have our great service like API gateways. You probably already heard about that. That's a high-level architecture diagram for API gateway. So in the middle, we have the API gateway service, and you always have a choice to have a CloudFront, which is our CDN network, CDN service in front of it. API gateway now supports like 3 types. One is like edge optimized, so we manage the CloudFront for you. And the other one is region-based, so there's no CloudFront, but of course you can just create your own CloudFront and attach to it. And we just announced a few days ago a private API gateway type. So you can just have your APIs be private in your VPC. API gateway can unify all your APIs, and then those APIs can talk to different services in their backend. Some examples, they can talk to like Lambda function. They of course can talk into EC2 instance, on-prem servers, or they can pretty much talk into other endpoints you like to. Then of course we do cache for you, and we do CloudWatch monitor for you. One thing I would like to call out is we do have a service called Cognito, can allow you to easily manage authentication and authorization. So a lot of times building authentication and authorization service is really non-trivial. Cognito greatly reduce this effort. Right. Next. For data. For a service world application, a lot of times you really don't want to also manage a database, right? It doesn't make sense because you have everything running on a service world. Why you want to have your own database on a server? You could use our managed service like IDS, but a lot of times people just choose DynamoDB. It's a NoSQL database, single millisecond kind of performance. It's that simple. You just get item, put item, delete item. You can also do batch. As a code example over there, based upon ID, just retrieve the data. So it's really simple. When it started, it's a key value kind of store. Now we support like a JSON, all those like data types. It also supports like streams. So when something happens, you create item in DynamoDB, it can kick off a stream. Then based upon the stream, you can do a lot of different things. You can replicate the data. You can trigger some other events. A lot of opportunities over there. Static content. So typical use case is you just put the pictures, videos, all those static content in S3. You can have a CloudFront in front of it. So basically, it's a cache layer, make it fast to access for your users. And for your business logics, you can just use Lambda. High-level architecture for Lambda. Out of the box, Lambda supports 5 language runtime: Node.js, Python, Java, C#, and Go. But underneath, it's actually running on a Linux container. So you can also bring your own code, just compile your binary, upload it. It also works fine. So I have a customer, they have a C++ program. They just compile, statically link their libraries, build a binary, upload it. Then they have a Node.js wrap, very thin layer, wrap against the binary. It works fine. Left side would be event source. So Lambda can take a lot of different events from different sources. For example, DynamoDB can trigger Lambda. If you drop file into S3 bucket, it can trigger Lambda. You can do it from API gateway. And the right side, when Lambda finishes, it can send events to different sources, or save the data into a database, or trigger anything from the internet if you have the connectivity. So put all together, your application running on a serverless world would be pretty much like this for a web application. You have a CloudFront to cache all the static contents. You can also associate a custom domain to your CloudFront. You even can have a web application firewall attached to your CloudFront. For the static content, it will be in S3. For your dynamic content, you can talk to API gateway. And API gateway can invoke Lambda, and the Lambda can do a lot of different things. Invoke your business logics, get the data, save the data into a DynamoDB table or tables. So that's great. Those are answers I just mentioned for all those requirements. Oh, what's next? You're so excited, you want to get started, but that's the first application. What are you going to do? We do have a lot of examples. We also have this serverless application repository. The idea is sort of like a GitHub. So when you have a serverless application, we allow people to upload it to this repository so they can share the code and reuse by a lot of other peoples. And we also have a service called CodeStar. So we do have a DevOps session for serverless. In this session, we're going to talk about CodeStar or our code build, code deploy, code pipeline services. But CodeStar does have a lot of like blueprints and examples inside. If you open, you create your first project, you can choose a serverless project. Then from there, it will create all the pipelines, the repository, allow you to hook to an IDE, and you can start developing your code. You find an example, maybe from serverless application repository, or from GitHub, or from internet. Now, what do? You need an IDE to develop the code, debug, and the testing. You need some CI/CD pipeline to deploy your code. What are you going to choose? So for a serverless application, we have something called a serverless application model, SAM in short. That's built on top of CloudFormation, which is our infrastructure as code service, basically allow you to come up with a template, and based upon the template, we deploy the infrastructure for you. Then we extend this concept, allow you to deploy your Lambda function API gateway to AWS. Because it builds on top of CloudFormation, so pretty much you can have everything in the template as long as it's supported by CloudFormation. It's open specification. It's actually on GitHub. so anybody can implement if you choose to. So that's a template. In this template, you can see we have different sections. If you have ever played with a CloudFormation, if it's JSON or YAML, typically the template will be pretty long. The nice thing about SAM is we sort of simplify it, so the template is really short. Then in this template, you can see we have a type. It defines a serverless function. Then you define all those properties, like runtime, it's Node.js. Then you define the policy. The policy allows the Lambda function to do different things, to have the permission to do that. You also can define the event source. For this one, it's actually from API gateway. So I define an API over there. Once you run the template, because I have an API over there, then the service knows, OK, you need an API gateway to host your API talking to your Lambda function, so it can automatically create API gateway service for you. At the bottom, I have a table. I just use the default parameters, so it knows you want the DynamoDB table, so it's create a DynamoDB table for those defaults for me. So you don't really need to specify a lot of parameters. We also have something called SAM local. A lot of times you start developing, you want to test it. Upload it to the cloud, yeah, it's nice. Sometimes it takes a few seconds. You have to refresh, and you want to test it. SAM local allows you to test your Lambda function, API gateway, and even like DynamoDB locally. So you can have a local stack running on your laptop. Then when you're ready, you just run it. It sends your event to the local container, and it comes back. So it does running on a local container. It's Docker-based. And we actually have this open sourced on GitHub. So if you have time, check it out. For the IDE, we have a very nice cloud-based, browser-based IDE called Cloud9. In this IDE, you can develop your code. You actually can test it. And actually, you can share the IDE with your teams. So last reInvent, we have a great demo, like to developers on a stage, like pair programming on the same application. Another nice thing is it has something already built in, can automatically shut down when you don't use it. You can specify, like, if I'm idle for 1 day or 1 week, it can stop for you. Then when you come back, you bring it up, you can start working again. It will remember your state. So I'm not going to talk too much about CI/CD, DevOps, because it's a big topic. But serverless application does work well with our code services, code build, code pipeline. If you have the same template, you check in the code, then it can just automatically deploy your Lambda function or your changes into AWS automatically. You can hook your source repository to GitHub or to code commit, which allow manage the private Git services. So we have our IDE. We can build our CI/CD pipeline. We can use SAM and code deploy to deploy our functions. That's great. That's great for a demo and for a POC. But if you want to build an application, you need the authentication and authorization, right? How are you going to manage your users? How are you going to protect your static assets and all the other AWS resources? That's a challenge, actually. What you can do is you can take advantage of like Cognito, our service, to manage the users and all authentication around it. Cognito has 2 capabilities. One is called user pools. You can think about it as a user directory. It can have groups, users, and all the attributes associated to it. It supports like OAuth 2. it can integrate with like SAML, OpenID Connect. You can set up to use Cognito with logging with Amazon, logging with Facebook, logging with Google. All those are supported out of the box. We also have very nice feature called host UI. So if you configure a little bit in Cognito, you don't even code. In your application, you can redirect to the host UI, and people can log in over there. With their authenticate, will pass back a token or a code to your application. Then you can start from there. You can customize this host UI. You don't need to do much about it. You just have a very nice authentication solution. You don't really need to build a code by yourself. Cognito does integrate with API gateway. So in the API gateway, when you create APIs, you can choose a different authorizer. You can choose a user pool authorizer, do the authentication for you. You can also choose a Lambda authorizer, do a lot more things. Because Lambda runs some code, so you can ask Lambda talking to your user directory if you host them in your data center. Or you want to do different logics based upon the user groups, for example. Once the user is also authenticated, then the authorizer can generate some policy for this user. And based upon the policy, the user can access different AWS resources. Right. So use all those services, you can quickly build a serverless application. Then as a good developer, you always want to refactor your code, you want to optimize, you want to enhance your code. You always have a lot more new features coming from your customers, your business side. Of course, you can do all those things in a traditional way, but today I'm going to introduce a new service. Before we do that, let's quickly review like RESTful APIs. You guys probably already familiar with like RESTful APIs. So you have all those endpoints. This example is about like a forum. You have all the posts, you have post info, and have all the comments for those posts, right? So typically you have a backend, and you fetch data, you go to the posts, you get the post data. And what if you want more information? Then you call another endpoint and get a title. You want to know the author. And you can be creative, do some endpoints like name starts with X, right? Then each post probably have a bunch of comments. You have to do the endpoints multiple times. Sometimes people call it like N plus problem. N plus one problem, sorry. So you do one, then you find that you have already need more data, then you have to do additional like N requests to get all the data back. So this example is like one post probably have like N hundred like comments. Then you get a post back, then you discovered, okay, I need all the comments, at least the titles to show up. So you make another 100 like API calls. There will be a lot of traffic for your applications. Can we do better? So there's something called GraphQL, initially developed by Facebook. It allows you just do one single request and get all the data back. So it's actual open specification. It's sort of like a protocol. It's not a graph database, by the way. But in the backend, you can use NoSQL database. You can use a relational database. You can also use the HTTP endpoints. How does it work? So first, you have to define some like schema. So for RESTful service, you don't really need to define a schema. You can define like data model, like our API gateway supports data model. Then you can validate against data model. But that's not a real like hard requirement. If you come up with your own applications, you can just do RESTful service as you wish. Typically, you do an API call, you return a JSON structure, then that's it, right? But in GraphQL, you have to define a type with all the objects. So here, we define a query, and the query has a get tools action, then it comes back a to-do list. Then in the to-do list, you have ID, name, description. Exclamation mark means it's like required. So you can have like int, string. Then you make a query. So in this query, you can see, I didn't ask for everything. I just need ID, name, and priority. It just returned this data for you. You can ask different things. At the back end, actually, I can talk to different data sources, run different code. They can aggregate together and just return the result you want. So some details. So first step, you define a schema. This example, it will be like event, have comment. Then you can see I have a list of comments in the event. It's array list, right? Then you define something called mutation. Think about mutation as post, put, delete in the RESTful word. It just changes your data. Then you do a query. Think about a query as a get in the RESTful word. You just get your data back. But for query, you actually can specify what kind of data you want. And the other nice thing is you can also have a subscription, which supports actually real-time update. So if you subscribe to something, somebody else updates this data, you can have a callback. Then you know something is changed. So you can update your web application or mobile application like simultaneously. So you can see like we subscribe to the event and comments. If somebody put a new comment, we know, okay, there's additional comment. Then in your app, you can just display this new comment. If somebody deleted it, you can do the same thing. So you got the events back. A lot of nice features for GraphQL. So it supports like real time. You can do batching. Pagination is also supported out of box. You can do relations. Of course, aggregations from different data sources. And there's a search is also supported. So in your query, you can specify different conditions, and it can return different data. And the last nice thing is it supports offline. So initial use case would be for mobile applications. So you really don't have great connectivity all the time, right? If you're in a tunnel or in a basement, then you update something, you make a comment. GraphQL actually automatically supports store the data locally and try to upload your data when it connects again. So you don't need to do anything else, which is really nice. Of course, you can create your own solution, like use WebSocket, local storage, but that's a lot of heavy lifting over there. But GraphQL just supports out of box. So I would like to introduce AWS AppSync. So it's our managed service for GraphQL. It supports all those like real-time capabilities, offline programming models. You can connect to the resource in a DynamoDB, Elasticsearch database, or you can just connect to a Lambda, which opens a lot of opportunities for you. It also do conflict resolution, because a lot of times if people are offline, they make some changes, there might be conflict. So we support out of the box how to resolve those conflicts. It could be client wins, server wins, or just ignore the other ones. First come, first win. We also think about security. So it integrates with Cognito. So you can use OpenID Connect to do the authentication and authorization. So that's a high-level architecture diagram. So first, you have a schema. You upload the schema to AppSync. Then you have to define a bunch of like data sources where your data comes from. It could be DynamoDB. It could be Elasticsearch. It can also talk to Lambda. So Lambda, of course, can talk into a relational database and your legacy applications or other like HTTP endpoints. For the security part, you can integrate with Cognito user pools and use OpenID to do the authentication. The other way around, if you already have DynamoDB tables, based upon those tables, actually we can generate some schemas for you, which is also very nice. So you might be wondering, now you have AppSync, you have API gateway. How I'm going to use them together, or which one I should choose? So a lot of people say AppSync, not AppSync, GraphQL is the next version of REST because it addresses a lot of problems of REST. That could be true, but we really don't force you to make a choice. And we understand a lot of times you already have HTTP RESTful service in your backend, you still want to talk to them. Or you want an API gateway, APIs, to aggregate different endpoints and have a unified API for your front end. So you can still use API gateway. But if you need offline, real-time kind of capabilities, you can use AppSync. So they can work together. So in my demo, actually, I'm going to show you how you're going to use API gateway and AppSync in the same application. So with that, I'm going to the demo. Right. Okay, make it a little bit for you. So it's first, I want to show you how the application looks like. It's really simple. It's give some custom feedback. So I already can see all those feedback I type in. And if I say I want to leave a feedback, first thing I would say, you want to already sign in one time. So I sign in. If you haven't signed before, it will ask your user ID and password. Okay, so I type in test. So I have test in the submit. So it puts into a DynamoDB table. And here I also have once you log in, I have the product menu for you. It's in a private bucket protected by my API gateway. So of course I click it, I can download it, right? So that's the first phase about my application. I just have a DynamoDB table, API gateway, and if you can see, I host my application. You cannot see, but I have a custom domain for my application, which is attached to CloudFront. So the next thing I want to show you is it's a single page web application. So that's the URL. So the first thing I want to show you, it's actually in Route 53 is our DNS service. So I do have a domain over there. So that's my domain. So you can see it points to a CloudFront. Actually, I can see, make it bigger for you. So it points to CloudFront. Of course, next thing I want to show you is CloudFront. So in CloudFront, I have this CDN. Origins is from S3 bucket. It's from my public bucket because I want people to access the web page, right? First time you need to see something and you need logos, homepage kind of thing. One thing I want to show you is because it's a single page web application, everything served by one page. So you do have to take care of your errors. If it's not found, you still have to redirect to your index page if you choose to index. That's one thing you have to make sure. Next thing, that's 3. So my application I deploy to a public bucket. So my private assets in a private bucket. That's how I host my static content. That's how the application deployed and hosted. So I'm using CodeStar. Our CodeStar service allows you to have a central place to see your application. So if you can see here, the right side, you do have a very nice code pipeline, different stages. So some developers checking a code, it can kick off the pipeline, build your application, and deploy to AWS. It can also integrate with your ticket tracking. If you're using Jira, it can be integrated. And it also integrates with CloudWatch, give you some metrics over there. I want to show you the project. So the project have a bunch of resources. You can click from here to go to, like, for example, API gateway. So that's my API gateway API. First thing I want to show you is for my post, how I'm going to do the authentication. So for the request, the authorization, you can specify here. Out of box, you can choose like IAM. If you're using IAM, you can use a CDK or SDK to build and signature. Send to us, we verify signature, make sure you're authenticated. Here, I'm using a Cognito user pool authorizer. So you build the authorizer from API gateway. It's very simple. You click a button, and you give it a name. Choose Cognito. Then you just choose your user pool. Typically, what the header looks like. Click create. Oh, already probably have it. Just create a one for you. Then you can attach it to your user API. So out of box, for the API authorization, we accept like an ID token, if you're familiar with OAuth 2. So the ID token has some ID information over there. If you want to choose access token, it can be done as well. So you have to define some custom attributes. Then you can use access token. The nice thing about access token is you can invalidate those tokens. So you can do a global sign out on one device. Then we will make sure that all those access tokens are invalidated. But ID token typically cannot do this. So I want to show you how to protect your static asset. So I have this resource here. Right side, it just talks to S3 directly. I'm also using the same authorizer to protect my assets. So when you call this API, you have to provide a folder, basically a bucket, and your file name. With this token, I know you're authenticated, then I just give back your assets. Otherwise, you just get denied. So that's this part. Next thing I want to show you is the Cognito user pool. So here I have some users. It's a user directory. You can define a bunch of like groups or other attributes. Out of box, we support email. You can specify like address, all those things you need. You can also create like custom attributes. You can create application client. In this client, you can define how you're going to use Cognito user pool. You can have callback URLs. Then for OAuth 2, you can specify the scope. We support 3 types. One is the code grunt. Basically means you're talking to Cognito, we return a code for you, and based upon this code, your backend has to get a like access token or ID token. We support implicit grunt, which means we return ID token direct for you, then you can just use it. You can also use client credentials if you have a backend service. Last thing I want to show you in Cognito is you can define your own domain here. And this domain opens the host UI page. So if you go to this domain, and it asks you log in and register your user. All right. That's for that. So the next service I want to show you is AppSync. So as I mentioned, in AppSync, you can define like schemas. So that's my schemas, mutation, query, and request. In AppSync, when you have this data source, you have created something called a resolver. So the resolver actually do the heavy lifting for you, talking to your backend, get the data back, and send it to the front end. So you can run your queries here. Then we have the documentation over there. Just like RESTful, you can have Swag documentation. We can have the documentation here. Then you can define data source. See, here I have the Amazon DynamoDB. So that's how my data comes from, how I define my API gateway, and user pools. So now I'm going to switch to my IDE. That's the Cloud9 IDE I mentioned. So you can do the develop over there. I have two projects. One is my backend, which runs on Lambda behind my API gateway. I have this SAM. I have this SAM template, which defines how my application looks like. So that's for my Lambda application, as I mentioned. I define the runtime, it's a Java application. Then I can enable X-ray, which is our service, allow you to monitoring end-to-end performance. So I do define like APIs, as I mentioned. I have a get, post, all those type of things. I define a DynamoDB table here. So finally, I just have output for my endpoint. Think about this template as sort of like your end script or Maven template. If you're checking a code based upon template, we're going to deploy the application, create our infrastructure for you. If you make a change, we're going to create something called a change set in CloudFormation and just deploy the change for you. So that's my backend. It serves all the dynamic content for me. For the front end, I have this simple page web application. I'm using a popular JavaScript framework called Vue. So that's the entry point for the application. Really simple. Just import all those resources. One thing I want to show you real quick is in this page. So for static assets, actually I do have the endpoint behind my private APIs. When you log in, you can get that. It's based URL. For the feedback for my dynamic content, I just go to the endpoint to get those from API gateway. The nice thing about Cloud9 is actually I can test my application inside IDE. So I'm going to show you that. So of course you can upload to S3 bucket and do a deployment and test over there. But for Cloud9, you do have a choice. You can preview, and you preview your wrong application. Yeah, I can just open to my browser. So that's the application. So you make a quick code change. It can dynamically refresh itself, give you a local development experience if you're familiar with like any IDEs, if you do the application development. So the last thing I want to show you in the application is the next phase is how you're going to use AppSync. Let me switch to my application. So let's open. Move to the right side. So I have this feature request. So you can see I actually using different browsers. Try to show the real-time thing. I have a feedback. So you can see immediately I have the same data on the right side. Want to show you a little bit offline capability. So in my Chrome, I'm going to make the network offline. So try again. I'm going to update my user interface. But if I go to my table, I do a refresh, I don't have the data because I'm offline. If I go to my another browser, I refresh, I don't have anything, right? So I'm going to make my online again. If I go to my table, I refresh, then you can see the data will be there. And if I don't even need to refresh my another browser, and my data just immediately showed up. So that shows you how you easily can do the offline capability, right? Under the hood, the offline capability actually is based upon WebSocket. It's running with MQTT protocol with WebSocket. Of course, you can build this functionality by your own, but there's a lot of heavy lifting over there. For AppSync, you can just subscribe to it, then boom, you have this feature. Almost like a painless. So that's my demo. Before I let you go, I think I want to show you how you can hook up with AppSync. So that's just the AppSync. You do a mutation, you do a request, and that's for the subscription. So with a little bit code, you get the data back when you subscribe. When you have the data back, you can just update your local cache and show the data. So because you already received data from AppSync. So that's my demo.